Now we're going to look at some more examples of composite function problems. These first ones that we were looking at are like numbers 3 through 5 on your assignment for 2.6. Okay, so we are evaluating each of these composite functions at the given value of x. So for number 1, what we are doing is we're going to evaluate f of g of 1. So first we're going to do is plug 1 into the function g. Okay, so we plug a 1 into x, and so we get 2 over 1 plus 1. And that is f of 2 over 2. Well, 2 over 2 is just 1, so we get f of 1. Okay, so we evaluated g of 1, and we got 1. Now we're going to evaluate the function f at 1. So we're going to plug in a 1 for x for that function f. So we have a negative 1 squared plus 1. That negative applies after the squaring, so we have a negative 1 plus 1, so we end up with 0. Okay, so this one, we are going to evaluate f of h of 2. So first we will plug 2 into that function h. So we get negative 2 times, replace the x with 2, plus 1. So negative 2 times 2, we get negative 4, plus 1. That's going to be f of negative 3. So we evaluated h of 2 and we got negative 3. And now we evaluate f at negative 3. So we're going to plug in a negative 3 for x, and so we get negative out in front of negative 3 squared plus negative 3. So this time we're squaring a negative 3, so that's going to end up being a 9, but then the negative out in front stays there. Plus a negative 3, so that's just minus 3. So we end up with negative 9 minus 3, which is negative 12. Okay, now let's look at g of h of negative 3. So first we want to evaluate h of negative 3, and that's going to go into the function g. So we plug in a negative 3 and we get negative 2 times negative 3 plus 1. Negative 2 times negative 3, that's a 6, and then 6 plus 1. So we end up with g of 7. All right, so we evaluated h of negative 3, and we got 7 as the result. And so now we're going to take 7 and plug it into the function g. So we get 2 over 7 plus 1. So that's 2 over 8, which if we reduce that, we get 1/4. Okay, so let's look at this one. We are going to evaluate f of h of 3/2. So we're going to plug 3/2 into h, and then that goes into f. So we get negative 2 times 3/2 plus 1. And evaluating that. So negative 2 times 3/2, well, those 2's are going to cancel, right? So those will cancel, and we'll just be left with a negative 3 plus 1. So we end up with f of negative 2. All right, so we evaluated h at 3/2, and we got -2. And so we now plug -2 into f. So f of -2, we get a negative out in front of -2 squared plus a -2. So negative out in front, -2 squared is 4, and then plus a -2, so we get -2, and that results in -6. Okay, so we have another kind of problem here, and these ones are like number 1 and 2 on the assignment. So this time we have functions given to us in table format, and we want to find these function values. So for number 1, we're looking for f of g of 1. So g of 1 is the inside thing, so we evaluate that first. So we're going to do f on the outside. Well, g of 1, we go over here to g. Here is 1, x equal to 1. Well, when x is equal to 1, g is 6. So what we're going to plug in there is a 6. And now we look at the table for f. We go over to where x is 6 and return the value of f when x is 6, which is 2. So our resulting function value is a 2. All right, let's look at the next one. F of g of 2. So f of, we got to figure out what's going to go in there. So we evaluate g when x is 2. Well, there is 2, and g is -2. So we plug in a -2, and then we look at f when x is -2. All right, we don't have any -2's in our x row. So that means that f of -2, it does not exist. So we say D and E does not exist because -2 is not in the domain of that function f. Okay, the next one, we want g of f of -1. Oops, not f, but g of f of -1. So this time we're going to look to that function f to start off with. So we go over here, we go to, well, there's x equal to -1, f is -2, so we plug in a -2 there. And now we look at g and go to where g is -2, or where x is -2, I'm sorry, x is -2, and that gives us a g function value of 0. So our result here is 0. Okay, so for number 4, we want f of g of 3. So we are first going to look at the table for g, and we go over to where g is 3. Well, it never equals 3. So there is no number no number we can put in there. So what we say is this is does not exist. It's not possible because 3 is not in the domain of g. All right, so let's look at number 5. We want g composed with itself. So g of 2. Okay, so g of, so we do the first one and we go to where x is 2, g is -2. So that -2 is going to go in here. And then now we have x equal to -2. We go to where x is -2 and g is 0. All right, last one, and we've got f of 3. So if we go to F, right, we see that 3 is not in the domain, so we can't actually evaluate anything to put in there. So f of, there's no value. Actually, don't want to put an x in there because that makes it look like it is something, nothing that we can put in there, and that does not exist. Okay, this example is like number 6 through 8 on the assignment, and we want to find the expression for f composed with g and g composed with f, and then also give their domains. We're going to start off by writing the domain for f and g. So f of x, the domain, well, there's no restriction because it's a linear function. It doesn't have the square root. It doesn't have x in a denominator, so the domain is all real numbers. For g of x, we do have restriction on the domain because we've got a square root. So we want x minus 3. We want that to be greater than or equal to 0. We don't want it to be negative. So we want x to be greater than or equal to positive 3. So in interval notation, we have bracket 3, infinity. Now let's find f composed with g. So f composed with g of x. So this time we're not plugging in a value for x, right? We are just wanting to come up with a new function. So f, and we're going to plug in g, which is square root of x minus 3. So in f, we replace x with square root of x minus 3. Meant to do that x square root of x minus 3 in red above. And then we've got the plus 1. Okay, so the plus 1 doesn't go underneath the square root. Okay, that's separate. And there isn't really any simplifying we can do here. So our final function, f composed with g, is 5 times square root x minus 3 plus 1. All right, now we want to look at what the domain is. So remember, we got to think about the domain of the input function, which is g of x, and that was 3 infinity, and then also the domain of the resulting function. Well, the domain of the resulting function is going to end up with that same domain because we still have x minus 3 underneath the square root. Okay, so this is the domain of our new function, f composed with g. All right, now we're going to have g composed with f of x. So g is the outside function, so we're going to plug in f into the function g. So we're going to plug in 5x plus 1 to x in g. So we're going to have the square root of, for x we plug in 5x plus 1, and then we've got, from the function g, we have a minus 3. So we want to combine that so we have just one constant term, so we get 5x, 1 minus 3, we get minus 2. Now we want to look at the domain. So the input function this time had domain of all real numbers, so we don't really have to worry about restricting the domain for the 5x plus 1, but we do need to look at the domain for the resulting function. This right here is underneath the square root, so 5x minus 2 needs to be greater than or equal to 0. So solving that for x, we get x greater than or equal to 2/5. In interval notation, that's going to be bracket 2/5 infinity. Okay, the final kind of problem in this section is to find the difference quotient. So the difference quotient, I have that there, and this is like problems number 9 and 10. Okay, so our first one, we have f of x equals negative 3x minus 2. So we start off by plugging in x plus h into that function. So we're going to take negative 3, replace that x with x plus h, and then we have the minus 2. And then we have a minus f of x, and so that is minus 3x minus 2. So we want to put that f of x in parentheses because we want to make sure we distribute that negative. Okay, so, and then that's all over h. All right, so let's distribute that negative 3. So we get negative 3x minus 3h, and then the minus 2. And then distributing that negative, we get negative 3x, so that's a plus 3x, negative times a negative 2, so that's plus 2. And then that's all over h. Okay, here we get to see that some things cancel out. And that's the great thing about difference quotient. Things cancel out. If they don't, then you want to look back and see if there's anything that you didn't quite do correctly. So we have a negative 3x and a positive 3x, and those are going to cancel out. We have a minus 2 and a plus 2, and those cancel out. So we are left with just simply negative 3h over h. And we can do some more canceling, and we get h's canceling, and we're left with just negative 3. Now, I do want to point out that if we look at our original function, we have negative 3, and this is a linear function, and that is the slope. And that is exactly what the difference quotient gives us. For a line, the slope is constant, and so we get a constant. That is just the slope of the line. One more example of finding the difference quotient. So this time we've got a quadratic. So we start off by plugging in x plus h for x. So we're going to have x plus h, and that whole quantity is squared. And then minus 2 times, replace that x with x plus h. And now we're done with the x plus h, f of x plus h. And now we subtract just f of x. So in parentheses, because we want to make sure we distribute that negative. Okay, so the f of x was in what I have in red. The f of x plus h is what I have in blue there. And then that is all over h. So here we need to multiply out. So x plus h squared, all right, we got to FOIL that. So that's going to end up being x squared plus 2hx plus h squared. And then we distribute that negative 2, and we get negative 2x, negative 2h. Distribute the negative in front of the f of x, and we get negative x squared plus 2x. And that's all over h. And now it's the place where we get to cancel stuff out. So we have a positive x squared and a negative x squared. Those go away. We have a negative 2x and a positive 2x. Those go away. And let's see what we're left with. So we're left with the 2hx plus hx squared minus 2h all over h. Now you'll notice that the numerator has got factor of h in each of those terms, so we're going to factor that h out in front. We'll be left with 2x plus h minus 2 all over h, and then we get to cancel out that h, so we are left with, for our difference quotient, we are left with 2x minus 2 plus h. So you got to trust me, this is the slope for the function f of x equals x squared minus 2x, but because it's a line, it's not a line, it's a quadratic, it's a parabola, the slope changes depending on what x is. And that is one of the first things that you learn and talk about in calculus. So difference quotient is something you will encounter when you move on to calculus.